Oh yeah. No, I just end up recording stuff for like this and some other stuff here and there. All right, so I'm
All right.
recording now. So if you can start the Discord stream.
Sure. Cool. So what I did basically just solves this puzzle that is right here. All right. So in this puzzle, you have a total of it's just a normal set puzzle, but there's a whole bunch of different possibilities. So there's probably some easy ones you guys might be able to see here.
Yeah.
But in total, it shows that there is 6 sets that are on this board, and your goal is to find all of them. So let me just switch over really quick. Let me just. Okay. So that's the goal. And so what I did is I just have a simple program right here. Maybe I can go one on the left, other one on the right. Okay. Here we go. Okay. Yeah, I am using Atom. Okay. So I just kind of input manually all the grid members. So you have the green, blue is the first column, red, blue, green is the second, and then blue, green, red, and so forth. So I just manually inputted all the information into this grid into these 4 columns. And there should be a much easier way to automate that. But I just kind of did it as simple as I could because I made this pretty quickly. And then I have this check set function right here. And all it does is it initializes an answer list. It loops through all the values of I, j, and k. So it just enumerates all the possible combinations here. And in total, there's a total of 220.
Oh, did you cut out for anybody else?
And what?
You cut out a bit for me. Hello?
Oh no.
Like I see him
me?
doing stuff, but oh, there we go. I hear him again.
Is that me or is that Gino?
It's fine on my end.
Oh, it's fine on. Okay,
Yeah,
I guess it's
sure.
just me.
So anyways, basically what my code does here is, so as I said, it enumerates all the possible combinations. There's a little bit of just making sure that it accesses the grid correctly. And what it checks is for each of these individual grid elements. So here's a grid that has 12 elements in it, for instance. It checks 3 combinations of values. So it says if the grid values are the same, so grid I is equal to grid J, and grid I is equal to grid K, or if they're all different, so grid I is not equal to grid J, grid I is not equal to grid K, and finally grid J is not equal to grid K. So
just a quick thing, you could probably simplify this. You can actually put the first equals all together in like one huge equal statement in Python. You can do 3-way equals Boolean.
I'm
So
pretty sure you
simplify
can't.
No, I'm very certain you can.
All right, let's
Do you
see.
like-
1 equals
Yeah, like
2 equals 2 equals 2.
Yeah, and then change one of the values. Yeah, told you.
So it doesn't do the C thing where it does like this?
No, it doesn't do that.
Oh, that's so strange. Anyways, okay. So
yeah, you
what
can
you're saying is
simplify
I
it.
could just...
Yeah, you can basically do that, and then you could also do the same thing. I'm actually not 100% if how it works for the not equal to.
3 not equals 2 not equals 1. 2 not equals 3 not equals 1.
Oh, that
2
seems
not
safe.
equals 1 not equals 2. No.
Oh,
Yeah.
it does break.
So that's where it breaks right there.
Anyway, okay,
you do
maybe
need
that one. Okay, but
so
at
you
least
do
the
need
first
to
one
kind
is a
of-
little bit simpler.
clunky syntax, but yeah. So
I'm not super sure why is the row calculated with floor and the columns calculated with the modulo? Why just split those like that?
that's just because this is a 2D array, basically.
Yeah.
So it was a 2D array, but in order to efficiently go through the loop, I treat each of the array indices as a index. So for instance, on the grid here, I would be like 0, 1, 2, 3, 4, 5, and so forth. But in order to go from 5 to an index, you just compute the remainder when you divide it by 3, basically.
Yeah, I do the same thing in my algorithm.
Oh, okay. I don't think I've seen that method before. Okay, let's go.
Yeah. So what this does is it takes like the index 5, makes the row variable 1 and the column variable 2. So it just quickly converts between the two. So it's a yeah, cool. So I just do this basically for every single one of the variables. So I just copied and pasted for shapes, I copied and pasted for numbers, and I copied and pasted for the fill as well. And so if either of those conditions are true, then it passes. Otherwise, it continues, which means it just goes to the next element in the loop. And if it gets all the way down to the very bottom, then you append it to the answers list. And at the end, you return the answers list.
All right.
So that's the entire idea here.
So if you run it.
Yeah. I don't know why I'm focusing super wrong repository. Okay. Windows sucks.
Yeah, do backslashes. It's finicky, yeah. If you're gonna be working in Windows, I suggest setting up the Linux subsystem, so you can use Bash.
Can I open that as a terminal in this?
I don't know if in Atom you can. You probably can, but I know that's what I do when I'm in Windows with VS Code.
Oh, nice. So, anyways, so what it did, it kind of shows it graphically, and it's just kind of transposed from how it is here. But you have, for instance, shape diamond, number 3, and the fill is empty. So that corresponds up here. Shape diamond, number 1, and the fill is F. Shape oval, number is 2, and the fill is S as well. All right?
Yeah.
So it just kind of visually shows the board. I know it's not the best way. So, but anyways, the thing that's much, much more important to us is this grid of numbers. And notice that there's 6 tuples, and those correspond with the solutions to the puzzle. So we go 0, 8, 11, and we take a look at that. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And right there, boom, 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 that's set. 1, 2, 3. This one's pretty easy. 1, 2, 3 is a set.
Okay.
Right, 1, 4, 9. 1, 4, 5, 6, 7, 8, 9. That's a set. 2, 5, 9. 2, 3, 4, 5, 6, 7, 8, 9. 2, 10, 11. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Here's a set. And finally, 5, 6, 8. It can be 5, 6, 8. And we got all the sets. And they give us a little congratulations
Nice.
message for that.
Yeah. The only thing I see with this, like, it works nice for, like, if it's fixed. But, like, if you do in the real time where the cards come in and out, it would have to be a little bit more dynamic, right? So it wouldn't necessarily find all the ones on screen. Like, if you were to convert it to be more dynamic, assuming you have the parsing thing already done, you'd probably, instead of getting every single one, you probably would only really get the first instance and then restart the process. Yeah,
basically. So, I guess to do is make it actually run in real time versus having, or just all that you really need to do is just manually fill these entries, because if you manually fill these entries, then you're golden.
Yeah. All right, so now let's go over brute forcing it.
Well, this is brute force.
Like the real time brute forcing it.
Oh, sure. All right.
All right, so I'm gonna stream now. All right, my screen's still sharing. Perfect. All right, so I'll share on Discord itself. Screen 1. I think we should be good. All right. Oh, goddamn, it's showing both my screens at the same time, eh?
Yeah.
Oh,
it is.
I hate that it does that. Hold on. See if I
can just streams.
Because I don't want to stream both. Because I want to have both on like one screen, right? Huh. Is there any? Wait, if I do screen 2, I think it did the same thing. Oh well. Looks like you guys are gonna have to suffer with Discord on the side. I can minimize it. Here, I'll minimize the second screen so it won't be as bad. Alright. Just gonna go with it. Do you need me? I'll make the text bigger at least so you can hopefully read what's going on. All right, so I do have the for that first part, right? I'm gonna be using pi out of GUI. Here I just get the size just to, as a quick test, right, to get like the dimensions. You can see the way with my multi-monitor setup, I get like super wide, and then the height is a little bit messed up, but that's whatever. But I won't really need that, so I'm just gonna delete that. I also have here the max number of rows, since it's gonna be changing right when we play. Say if I start a new game by myself, number of rows might change. Sometimes it's 4, sometimes it's 5, so we can probably change that to a variable. Here I'm going to be converting a number to the coordinate, right? And the same thing as Justin does, where I take the modulo and then I also take the division and floor it. And then I'm going to be employing the same strategy where I loop through it like one-dimensionally, but then I actually get a coordinate. So now, and here's where we're literally going to do this live. I was almost going to swear. Documentation. I'm going to look up how to actually click and stuff like that. Because the idea is basically, we have like this is what is essentially a grid. As you can see when I was testing earlier, it'll iterate all the possible combinations of clicks, right? And so we're essentially gonna go over like actually moving the mouse and then clicking, right? And then once it finds one, it'll just restart, and we can probably.
So you're using an auto clicker?
Yeah.
Oh my goodness, buddy.
That's what Python.
I mean, it works. If it works, it works.
That's what I'm trying to drive home here. All right, so let's do cheat sheet.
Oh my goodness, this
mouse
is
functions.
mega cheat.
All right, so now we can do a move to. Oh, we can even pass the durations. I wonder what the default is for something like that. So now we have like all our combinations. So for each combination, we're going to do a. Let's just call this. Whatever. I won't make it too fancy. I'll just do it within here. So pi out of GUI dot move to. I'll move to those coordinates. So we actually have to get that grid coordinates to actual pixel coordinates. So for now, I'm just gonna make a X and Y. I'm just gonna make them both 0. But I think you pass in X, you pass in Y. And then you pass in a duration. Oh, cool. So if you don't pass anything, it's instant. Cool. So you pass in here. And then you would click. So let's say pi auto GUI dot. Is it right click or double? It's right click. Oh, no. I think you just do click. There we go. Yeah, so you do click. Oh, wait. Oh, we can simplify this with just the one click, so we don't have to move our cursor. Even better. Cool. So moving to this, and then we'll basically, I think it might have a delay. Click number of clicks, interval between clicks, button left. Cool. So we'll just do that 4 times or 3 times, and that'll like be one round, and then it'll go through every other one again. Now we actually want to get our coordinates, and this will be very hard coded into where we actually want. So I'm just gonna make a second script just to kind of get my screen position. So mouse position dot pi import pi auto GUI, then we'll, while true, we're gonna go over and print pi auto GUI dot mouse info. I think that's what you want. Oh no, it's just position. There we go. Do \R and then flush. I'm trying to see flush equals false, so flush equals true. Alright, so this will just quickly, oh, not that one, I want Python Mouse position. Yes, Justin. That'll appear in the video. There you go. So now I get the real-time positions.
All right,
So-
yeah, I'll be back in a bit.
All right, it's all good. So we know roughly the first one will be, actually somebody can note this down real quick. So like 172.20, so 172.2 and then 5455. And then second coordinate will be, there will be an offset of like, shit, I don't know. Actually, I'm gonna note these down here. Or actually I'll just make a function. I'll make a grid to pixel, which will be a, oh wait, just realized something I want to make end, end equals just empty string. If I rerun this one, there we go. Now it only makes it a little bit nicer. It doesn't take up all that. Cool. So now we can get this grid, so we know it's gonna be a chord. So grid chord, which I know it's gonna be a tuple, and then it's also gonna return a tuple. And now we basically need to do the math. So now we know the base x and base y is going to be equal to, what is it, 1720, so 1720, and then our y is like 545-ish, if I can type in correctly, 545. And then we know that when we want to offset, we'll do offset x and then offset y. Let's see, what is the, so let me do the math here. So we start off 120-ish. That's like roughly the middle. And then we go into the middle of this one. So set 1720, and then here the middle is like 1915. Quickly do the math here. So 1915. Huh?
It's around 195.
Damn. Quick maths. 195. And now we just need the y value. So we know we start off, again, 545. It's roughly in the middle. We go down here. Use 666. Oh, wow, nice. Or like 665.
120 about.
120. Coolio. So now we know these are the offsets. So now what we can do is we get the grid chord. So we know the first one's going to be the x. So we make x plus, or so we know it's going to be the base x plus whatever the coordinate is in this actual grid times the offset. If my math is correct, this is the correct formula. Then base y is going to be grid coordinate of y times an offset. Actually, I saw one error. It's actually going to be 0 and 1 specifically. There we go. And that should, if we return x and y, that should return the actual places to click. So now if we do grid to pixel of, no, I don't want to use that. Do grid to pixel. Oh. And we pass in, what values do you even have to pass in? We pass in chord, convert to chord. So this will convert to our grid coordinate, and then here all we have to do is pass in first. That will give us the values here. And then we have to do this every time. So we do that here, here, and here. Second, and third. So now, in theory, if I kill this, this should work. At least for one instance, it'll run it through at once. So now, oh,
Is there the risk that it won't register movements that are that quick?
there is a possibility. We'll find that out. This is literally done live. I have not tested this. So now if I run enter, see, now it's just clicking through everything, every single possibility. Good thing you're not hearing the sound that I'm hearing, because it is pretty annoying. Another thing we could probably program in is a kill switch, because I don't know, because now since it's not focused on the terminal anymore, I can't do Control C. It won't be able to kill it. I need to let it actually run all the way to the end. See, it's still the second one, so it's actually kind of takes quite a while, as you can notice, because there is a lot of combinations, but it does seem to run it as fast as you can actually run this. I feel so bad for the video being recorded now.
What is that?
Because it's hearing all the beeping sounds. Oh, see, now it continues. Oh, wow, it actually found another one somehow. But it needs to run the rest of this all the way to the end. Which hopefully it will very soon, because it's almost over. There we go. So now it's done. First I'm going to mute this. I should have done this from the beginning. But yeah, as you can see, we actually got lucky when we found 2 sets. And that's how you do it brute force style. And then yeah, there's a couple improvements you can make to this. So for example, first of all, make a kill switch. If you want to just stop the program prematurely, but also you can make this fancy having this in like some sort of while loop, and then maybe you could in real time somehow like change the number of max rows that we're looking at. There's quite a bit of improvements you can do this, but this will do the trick, you know. If you set this up correctly, you can, and you're stuck in a question, you could run this in theory, and then it should work for you. I don't know. Let's see if I can do a kill switch. Keyboard functions. We can write, but I don't know if we can receive. Like, fail saves. So we can send in a pause between calls, and that will kind of make it easy for us to kill it. Moving the mouse to the upper left will raise a fail-safe exception that you can abort your program. This would work nice if it wasn't clicking every single interval. Oh, I think this is what we want. So we can set up a hotkey. Oh no, this is to simulate a hotkey. Yeah, I don't know. I don't know how we do the kill switch. Somebody could look into that maybe, but that would basically be it. I'm gonna stop streaming now. I'm actually gonna. Oh,
I would probably.
Never mind. I actually disconnected by accident. I also stopped recording.